Math Morning, this is Mr. Durkis. Today we're going to do part 1 of the linear equations project. So copy these notes down, and to make sure you're really getting everything, don't listen to music, don't watch YouTube. Do your best. You got this. Mr. Durkis out.
Okay, the first property we're going to talk about today is the additive identity property. It goes like this. Any number plus 0 is going to equal that number. Or 0 plus any number equals that number. An example of this, you could say 12 plus 0, that equals 12. Or 0 plus 12 equals 12. So any number plus 0 equals that number. The next property is the additive inverse property. That says any number plus its opposite number, which I'd say is the negative version of it, is going to equal 0. Or if you start with a negative, for example, negative a plus the positive version of that a is going to equal 0. An example, I could say 2.5 plus a negative 2.5 is going to equal 0. Or negative 9 plus 9 also equals 0. So any number added to its opposite version with a sign switched is going to equal 0. Alright, the multiplicative identity is next. That says that any number multiplied by 1 is going to equal that number. Or 1 multiplied by any number will equal that number. Example, 1,372 times 1 is going to equal 1,372. So any number times itself equals itself. Alright, next we have the multiplicative inverse property. This says that any number multiplied by 1 over that number is going to equal 1. So this happens if you multiply the numerators, a times 1, that equals a, and on the denominator it stays a. A over a is going to equal 1. The opposite of this, if you take 1 over any number, I'll use x this time, times any number, it will still equal 1 because this becomes x over x, and that equals 1. So example, 1/3 times 3, well, that becomes 3/3, and that equals 1. The opposite version of this, if you do 3 times 1/3, that's going to be 3/3, and that equals 1.
You made it through 4 properties. Keep it going.
Now we're on the commutative property of addition. This says that any number plus a different number equals that other number plus the other number. Huh? What? So what this really means is, here's an example. 3 plus 2, well, that's going to equal 2 plus 3. If you're adding two numbers and you switch them around and you add them again, it's going to be the same thing. The next one, the commutative property of multiplication, same as the addition one, but it's a multiplied times b is going to equal b times a. So again, right, 3 times 2 equals 6, and 2 times 3 equals 6 as well. Now we're on to the associative property of addition. So this one, we're going to put some parentheses in there. We have a plus b plus c is going to equal, parentheses, a plus b plus c. What? All right, let me explain. So if I had 1 plus parentheses 2 plus 3, that equals, parentheses, 1 plus 2 plus 3. All right, this works if you do parentheses first. So 2 plus 3 is 5, and I have 1 plus, back that up, 1 plus 5, and that equals 6. On the other side, I do 1 plus 2 first, that equals 3, and 3 plus 3, that equals 6. All right, the next one is the associative property of multiplication. Same thing, but with multiplication. So A multiplied, parentheses, B times C, close parentheses, equals, parentheses, A times B, close parentheses, times C. Okay, same idea. I'm going to do 2 parentheses, that's multiply, times 3 times 4, and that should equal, parentheses, 2 times 3, close parentheses, times 4. So on the left, I do 3 times 4 first, and that's 12. So I have 2 times 12. 2 times 12 equals 24. On the right side, I do 2 times 3 first, that is 6. 6 times 4. 6 times 4 is 24.
I see that you're doing great. So keep that up. You got this. Keep it up.
All right, we are on the back side now. We are on the distributive property of multiplication over addition. This is saying that A multiplied by the parentheses of B plus C is going to equal A times B plus A times C. So distribution, I think most people remember this. You have a number, let's say 3 multiplied by 1 plus 4. You do 3 times 1, which is 3, and then 3 times 4, which is 12, and you add them together. This could be written as 3, instead of 3 times 1, write it down here, 3 times 1 plus 4 times 1. Alright, and that's going to equal 3 plus 12, and that equals 15. Alright, next one, we've got the distributive property of division over addition. That's right there. So this one is very similar, but with division. Alright, this says that x plus y divided by z is going to equal x divided by z plus y divided by z. An example of this is 4 plus 6 divided by 2. That's going to equal 4 divided by 2 plus 6 divided by 2. If I solve the one on the left, I know 4 plus 6 is 10. 10 divided by 2 is 5. The one on the right, 4 divided by 2, that's 2. And 6 divided by 2 is 3. And I know that 2 plus 3 equals 5. Alright, next we have the addition property of equality. This says if A equals B, then A plus C must equal B plus C. So if two things are equal, example, if 3 plus 4 equals 7, and in this case the 3 plus 4, that's the A. Alright, and the 7, that is the B part. So those two things are equal. If I add 5 to either of those, so let's say 3 plus 4 plus 5, that must equal 7 plus 5, because I still have the A, right? 3 plus 4. And the 7, which is the B part, they're equal, and I'm adding something that's equal to both of them. Alright, so I'm adding the 5 and the 5. The whole thing is still going to be equal. So when you're solving equations, an example, you could say if x minus 5 equals 12, right? Then I always say, oh, get rid of this 5. But what you're really doing is doing x minus 5 plus 5 on the left side and 12 plus 5 on the right side. You're adding the same thing to both sides of the equation, and the whole equation will still stay equal. That is the addition property of equality. The subtraction property of equality is very similar, but with subtraction. So if A equals B again, then A minus C must equal B minus C. An example, if x plus 12 equals 20. Alright, so these two things are equal. Then, if I subtract the same thing from both sides, they'll be equal. So I could say x plus 12 minus 12 must equal 20 minus 12. So the original equation, right, x plus 12, I would normally say, hey, do the opposite of plus 12, do subtract 12. Well, that's what you do on both sides of the equation, and you can do that because of the subtraction property of equality.
4 more to go. You got this. 4 more. 4 more. 4 more.
Alright, now we're on the multiplication property of equality. This is very similar to the other ones. It's A, if A equals B, then A times C must equal B times C. Here's an example you've seen before. If x divided by 3 equals 5, then I always say multiply both sides by 3 to get rid of the 3 on the bottom there. So 3 times x over 3 equals 5 times 3. If you multiply both sides of the equation by 3, it's still going to be equal. Alright, the division property of equality. Again, if A equals B, then A divided by C must equal B divided by C. Basically, if you divide both sides of the equation by the same number, they're going to be equal. So, example, if 7x equals 84, then you can do 7x divided by 7 must equal 84 divided by 7. If you divide both sides by the same number, it's going to be equal. Alright, 2 more to go. So, the symmetric property of equality. If A equals B, then, drum roll, B must equal A. So this one, you can just change what's on either side of the equal sign. So if x equals 5, you're allowed to go 5 equals x. That is completely legal to do. Okay, last one, the transitive property of equality. So if A equals B and B equals C, then A must equal C. For example, if 3 plus 9 equals 12, and I know that, let's see here, 2 times 6 equals 12, then it must be true that 3 plus 9 equals 2 times 6. Right? Because if you look back, the A's, right, that's 3 plus 9 and 3 plus 9. A equals B. B is 12. Alright. Those are all equal, and that must equal C. And C are all the other numbers up there. 2 times 6. 2 times 6. Alright, so you did them. That's all. Nice job. Because you finished, I'm going to show you this video. Let's see if you can find back when I used to be a model. See if you can find me. Could you find me? All right. If you didn't, let me find it for you. Let's see. Let's see. Ah, look at that guy over there. Look at that guy. I told you I was a supermodel. All right. Nice job. Move on to the next section of this project. Keep it up.